Okay, I'm really excited, so I'm gonna get going. So here we go. First, I want to say that I'm not like super plugged into the Valley's amazing people, but for my part, Ethan is the authoritative source on event sourcing, like for all things. So there you go. So I loved, thank you. It was very reminiscent of last year's Utah.js, which was from also the only thing worth my time at Utah.js last year. And it was amazing. And this was amazing, and thank you for that. Also, Ethan and AJ might be some of my two favorite people, and them interacting today was bliss for me. So thank you for that. I'm going to be talking about function composition. And one thing I always try to say when I'm starting is that I prefer a very informal kind of presentation. So at any time, if you're like, whoa, dude, that didn't make any sense, hold it back up, or you have a comment or whatever, just shout it out. This is about learning, not about me. So let's learn. So who's heard of function composition? Heard of it? Who can give me like a really brief definition?
Are you meaning like hurrying type of thing?
Kind of, but not really. No, they're orthogonal but related. Well, let's look at these guys right here. Let's start with this first. Have any of you seen ridiculous functions like this in code? Like that top one. I have a function that takes an argument and immediately returns that same thing you just gave it to. Does that sound useful? I get a lot of why. How about map? Does an array already have that? Why would you write a function for map? A function that just returns true. Give it anything and it returns true. Give it anything and it returns false. Do these seem like valuable functions to you?
No.
Most people I talk to say no. Why would you do that? This is ridiculous. Hopefully, by the end of this, we'll say, oh, okay, I see why you would use that. That totally makes sense. Great. If not, then I failed, and we can move on. But let's talk about this counterintuitive pattern that will simplify your code, help you ship faster, be more stable, and grow thicker, fuller, healthier hair.
Yes.
It is function composition. But we're not really going to be talking about function composition. We're going to be talking about function decomposition, because that's probably what you're going to be doing. You're going to be refactoring. But we're not really talking about function decomposition. We're talking about something called function factoring. Who's heard of function factoring? Okay, this is what we're going to talk about. Function composition, according to Wikipedia, is an actor mechanism to combine simple functions to build more complicated ones, right? This is kind of probably when you're trying to describe, you may have used some description like this to describe like software engineering generally, right? Or an approach to software engineering. You take a problem and you combine smaller things to produce a larger thing. Function factoring is the inverse of this. It's the process of taking a complex system and breaking it down into parts that are easier to conceive, understand, program, and maintain. So it's probably the steps that you take when you're trying to solve a problem, right? You say, all right, we have this huge problem. What do we need to do? What are the steps we need to take to do this? If you guys follow Scrum, then that might be breaking down your epics into stories, that kind of mentality. This is a very common process that we all go through, and this is this is kind of a formal application of that process into coding. And it's probably more, especially when you're introduced to the concepts of functional style programming or just new concepts, and you want to introduce them into your code, you're going to be changing existing code rather than writing greenfield things that implement this, which is amazing and everyone loves that, but it's, at least for me, not where I tend to live. I tend to live in existing code bases that need refactoring or whatever. So this is why I think this is more applicable than just function composition. Once you learn function factoring, function compositions, it's easy, it's obvious. So what we're doing is taking a very, very complex problem, like you see over here, a function that does many things, or even a system that does many things. In this case, we're cloning it, we're adding a property, we're logging out, and then we're checking to make sure that we're valid, and if we're not, we're throwing, or aborting, right? And then if we succeed, we're returning that clone. Function factoring would be looking at that and saying, oh, I see, I have a clone step. I'm adding a property. Exactly what I said there, right? So we're factoring out these smaller parts from the larger part. Now notice what I said. I said we are cloning, we are adding a property. I could have said we're adding foo property and setting it to bar, but that's too specific. We want to look for generalizations, and hopefully that will make a little more sense in a minute. But it's important that we look at the generalization. What are we doing? Not what specifically are we doing, but what kind of thing are we doing? We're cloning, we're adding a property, we're logging, we're asserting, we're returning. If we do that, and we compose those, we create functions that do that and compose them together, that would look something like this, right? We assert, we log, we assign, we clone. What's the first thing you notice about this?
It's in reverse order.
It is in reverse order. Why is it in reverse order?
Because you've got to pass the result of the clone to assign, and the result of assign to log, and the result of log to assert, and then return.
Right. So when you're composing functions together, they compose inside out, so outside in, and again, this will make a little bit more sense in a minute. But also, do you find this particularly readable? More readable than, say, this?
Yes, because it uses two-space indentation.
Touche. I think, there we go. Yeah, that was just my mistake. Most people, and I would agree with them, would say, no, this is not more readable. So why would you do that? Dude, you're not helping, like with this. So let's take a step back for a minute. Let's imagine a scenario, a world in which we could just, in our programming, just say, here's what I want to do. Just do this. Not specifically go step here and then mutate this thing and change it, and then, not giving the very specific steps about how to make a sandwich, but we can say, make a sandwich. Or make a peanut butter and jelly sandwich, right? You don't really care how the sandwich is made. That's determined somewhere else. You know that the system knows what a peanut butter and jelly sandwich is. You can just say, make a peanut butter and jelly sandwich. So rather than spelling out every step of how to do something, how about we just declare what? Not worry about the how of the what. At least not at a particular level, right? The definition is defined at a lower level. But when we're programming, we want to be programming at this higher level, this higher abstraction level. That would be ideal. So conceptually, it might look like this, right? This is pseudocode. It's not real. It's not JavaScript. Doesn't work. But conceptually, we want to take a function and we say, all right, here's whatever data I'm working on. Call it context. I'm going to take my context. I'm going to pass it to clone. That's what the little arrow means. Context goes to clone. Whatever comes out of that, I'm going to give that to this assign function. Whatever comes out of that, I'm going to pass it to log. Whatever comes out of that, I'm going to pass it to this assert. Does that read better?
Yeah.
Does it read better than the more imperative one that we had initially? I kind of think it does. Do you really care how we go about cloning or how we go about assigning? I mean, you might care at some point, but do you care generally right now? Hopefully not. Hopefully that decision has been made either by you or by your team at some point earlier about how do we clone within our system? How do we clone an object? How do we assign properties? These are very stupid, dumb examples, but you get what I'm saying. We've already defined at some other point prior to this the details of how we accomplish certain kinds of tasks. We no longer have to think about the details of how we accomplish these kinds of tasks. It's taken care of for us. We can just say, clone it. Maybe we've decided we use underscore. So we're going to use underscore clone. It doesn't matter. It's irrelevant. We just want to clone right now. If you've used, if you guys are familiar with Unix systems in the terminal, this is Unix pipes, right? That's how they work. Somebody else wrote those functions for you. You don't really care how they work, just that they work. So, you guys ever play this game? So I'm giving my age a little bit here. I love this game. It was so fun. I spent hours doing this. And this is effectively what we're doing, what we're trying to accomplish with our programming these days. We're building pipes. We're just laying pipes. Like, all right, well, this end connects to this end, and then that end connects to the next one. This is what the majority of my time is spent doing these days professionally. You know, that as a metaphor, not in reality. Now, what we mentioned before, composed functions are evaluated inside out. So you notice in our arrows, we had to start with context because we start with the context of what this function is, the data that it's being presented with. The first thing we do with that data is we clone it. And you can see that's at the bottom, not at the top. After we've cloned it, we assign a property to it. After we've assigned the property, we log it. After we've logged it, we want to assert that it's valid. So order is important, right? And just composition means inside out. That's why it looks that way. Any questions so far? Have you guys used compose before? Who's never heard of compose? Compose. The generalized function called compose. The concept that may be implemented in any number of libraries or whatever. Compose. Function composition. No. Then great, this is for you. And it looks like this. You see that context, like the arrows now go backwards, right? Ba-doop, 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 up through there. Now, a lot of people find this confusing. A lot of people see this as like, it's backwards, and it's super confusing. Why does it have to be backwards? Why can't it just go forwards? And there's a reason for it, because function composition looks like up at the top. If you were to actually write this out, who writes React? Anyone write React? Do you use higher order components?
Yeah.
Do you often have multiple higher order components that you compose together? Like maybe you have connect, but you also have with router, and maybe a handsome one that you wrote yourself. And your component needs all of them. You would do like, all right, you have your component that gets passed to with router, that gets passed to connect, that gets passed with authentication higher order component, and it looks kind of like this up here, right? I find that kind of ugly and hard to read, unless you like, Scheme or something. I don't know, Lisp. But if we were to replace those parentheses with arrows just to point out the directionality of what's going on here, that down there looks a little more readable. Still, it's backwards, but at least the arrows indicate what's happening. A little bit better, right? See, I got it in there. But we want something that's more like the Unix pipe, right? Sometimes, maybe we don't. I like compose, but a lot of people would prefer it in more read order, the way you would read a sentence. So compose is not pipe. Let's get to that in a minute. The many libraries that are out there already offer a compose function. It's actually called compose. So Redux exposes a compose function. Do you guys know that? You can do redux.compose, and it does exactly what we just talked about. Recompose has a compose. What else did I put in there? Underscore, Ramda, Lodash, like many libraries that you're probably using actually have a compose function that you can use, that they expose. Did you know that? Like it's like everybody has it, but not like very few people use it. And it's interesting to me that discrepancy. Why would the libraries not only have it and use it internally, but then expose it? They must think it's valuable somehow. Why are we not using it? I would argue we're not using it because we're not following, we're not doing function composition or even function factoring. We are in the same context, in the same function context, diving between different levels of abstraction. And this, I think, in my opinion, is the hardest learning curve to get over when beginning to understand concepts of functional style programming. And this is ultimately what we're talking about, functional style programming. Functional style programming kind of requires that you exist inside of one level of abstraction. You don't dive down into a lower level and up to higher levels all within the same context. It forces you to create, to draw hard lines between those contexts, those levels of abstraction. And we're not used to that generally. We want to use our for loops because we can see what's going on here, even though later on we're using, something that's a little higher level. Maybe we're using, I don't know. It'd be kind of odd to use a for loop and a map in the same function, but I've seen it. But we tend to go in different levels of abstractions, all within the same context. And that is weird, honestly, if you stop and think about it. So, moving on. Sorry if this is a little all over the place. I don't have an excuse, it just is. That's where my mind works. There is an alternative to compose, the compose function. It's called pipe. Weirdly, most libraries that expose compose do not expose its counterpart, pipe. I don't know why. Just whatever. But when I have talked to some of my coworkers and helped them to understand functional style programming, the number one request I get is, why can't it just go forwards? I introduce them to pipe. Like, why didn't everybody use pipe? I was like, I don't know. Why weren't you using compose? It's just it takes time to get over. But this is, I think, is a good get your feet wet into this concept of function composition. It lets us do function composition in an order that we can read as we would a sentence. So pipe, we can, it helps, okay. It helps to see an implementation. Did I not do that? Yeah, okay. Helps to see an implementation. This is compose. You can see it takes functions, any number of functions you give it. Then it returns a function. It takes functions, and then it returns a function. And then it takes what I'm calling context. Once you pass it context, it takes the functions you gave it previously. It does a reduce write on it. And then out spits the result of that composition, right? Why reduce write? Because it goes backwards. Pipe, I mean, it's identical, except it's now reduced instead of reduce write. That's all. That's all. Pipe makes it feel better. That's all. So, yeah, this brings us back to the beginning of the talk, where I asked the question, why would anybody write these kinds of functions? Well, you may be thinking, that's cool and all, bro. Function, compose and pipe. That's neat. I like that. That doesn't really answer why somebody would create those weird functions like that. But let's break it down a little bit. The crux of the matter, the reason why these functions are valuable at all and why they are re-implemented from something that currently exists in the language itself is exactly because of context. That thing upon which you are operating. The value that you get out of function composition or the result of function factoring comes from the constraints that you're required to operate under. And incidentally, this is probably also another reason why functional style programming has a hard learning curve and why people don't start with it. Because they would prefer to start with the world available to them. They want all of the tools. And so and you end up with a kind of a hot mess. Have you guys ever taken art classes, like in college or whatever? Or graphic design? So I had a graphic design class in college, and one of the things that was really drilled into us from the get-go was that you cannot create good art or graphic design without constraints. So some of the best works of art, some of the best graphic designs have been done because the creators of them did not have their entire toolbox to work with. They had maybe a tight deadline. Maybe they had the constraints of the media in which they had to work in. Constraint is the mother of creativity.
Is that why you procrastinate?
Actually, I do really well under tight deadlines, probably for that reason. Yeah, so, and I think constraint is the mother of beauty as well. That's why, part of the reason why I think functional style programming is beautiful, because it operates within some very particular kinds of restraints. Those restraints are with respect to function composition, that functions can only take one argument. Now, in JavaScript, functions obviously can take any number of arguments. How many things can a function return in JavaScript? One thing. So it can take n things, return only one thing. That's a constraint of language. It's also a constraint of function compositions. Functions can only return one value. Did you know there are languages where you can return multiple values from a function? I think that's weird. It's weird.
Well, isn't that what destructuring is?
You could make the argument. Yeah.
Done.
Yeah.
But destructuring lets you have this, put one in, take one, and send and return one, and still have your cake. Because you put an object in, and you just stick all your arguments as properties on an object.
Yeah.
And you return an object or an array, and you structure it on the outside.
Right. It's you can think of it that way, but I would challenge you not to.
It's like, it could be done. I'm not saying.
Yeah, it can be done. You can take the tool, the constraints that are given you, and you can bend them to almost the breaking point. But the constraints are there really for your benefit. And if you lean into the constraints, I think you'll find that they help you a lot. So even while, and this is kind of also the value of type systems, right? Type systems exist precisely to give you a certain kind of constraint, in order to provide a certain level of security and other valuable things. We don't have a type system in JavaScript. Don't need a type system in JavaScript, in my opinion. But that doesn't mean constraints aren't valuable. So we can, in this new world order, functions can only take one argument. They can only return one argument, and the value returned from the previous function that was just executed inside of a composition becomes the argument for the next function. And this is why we call it pipe. Because it's like fitting pieces of pipe together. As the water flows through the end of one, it flows into the beginning of the next. Like a pipe. One input, one output. And if you remember that from algebra, that is actually the definition of a function. A single input produces only one output, otherwise it's not a function. As we compose these functions together, you can see that nicely the input of one function the output of one function becomes the input of the next function, and we can chain these together ad infinitum, provided that they match up. Yeah.
Isn't this similar to what promises already do?
Oh, that is a fantastic question, but you're getting ahead of me a little bit. We'll get to that. But the short answer, absolutely. Promise chaining is a form of function composition. And, I might add, most people use it incorrectly. So we're back to this idea. So again, context is everything. Context. The thing that is flowing through your pipe. This is what your context is. So if we look at map and filter and these array prototype methods, what is the context that these methods are operating on? Yeah, right, I tried to make it easy. The data that these methods are operating on is the array itself, right? That's inside of there. So that doesn't line up with our constraints, though, does it? If we want to iterate over a list of things, that list of things has to be the only argument in the function. But it's not an argument. The method itself is a property of the data. That works well for certain methodologies of programming. It doesn't work well for functional style. So we could turn it into this. We could still use the method on there. We just pass in the array. And then we say, hey, array.map. The thing I just passed you, get its map method or filter method. And so now we have our context is an argument. What if you need more information than just the context, though? Like, say, maybe you're using map. What is another piece of information that is needed in order to perform your mapping? I'll give you a hint. Wait, which one's the cool button? The pointer? Found it. Oh, yeah, it was already up there. What would you call this? The callback. You could call it that. It operates much like a callback. I call it the mapping function. Either way, whatever works for you. This is the generalization of this. Well, of this. Or that.
It's still assuming you're operating on an array.
It is. But that's part of the contract that this function has. The function is that your context is an array. But see, we're again violating our rules here. How many arguments does this map function have? But it needs both of those. So what do we do about it? Well, one thing, we're going to need to reverse the order of this out of the gate. And the other thing is, actually, we need to make them different functions altogether. Why? Because the rule is our function can only take one argument. But the cool thing is, and it can only return one thing. But the cool thing is, we can always return a function, which is what we're doing. So what we've done is we've taken the concept that we have, the generalization of mapping, and we say, all right, mapping, in order to map, we need a thing to map over and a thing to do while we're mapping. Two things. What is the context of map? It's the list, right? Which is why the list has to be the last thing that we deal with. Because we can't give other information after we've already put the pipe together. So if you can imagine, and I was going to bring some PVC pipe and make these little things, but I ran out of time. If you can imagine a PVC connector that has a branch coming off of it, and you imagine we have this pipe going on and there's a little branch coming off the pipe that we can feed stuff into. This is kind of what we're doing here. We're feeding into our map function that's going to iterate over this context. We're feeding it some additional information beforehand, right? Because we know what we want at the time of that we're authoring this code. We know what we want to do to the code, right? We can expect an array of a certain kind, a certain shape, certain whatever, and we know what we want to do to it. That's our mapping function. What we don't have is the actual data at the moment. We only have that at runtime. Agreed? So we wait to get it at a runtime. It comes later, so it comes later. That's the way I think of it. But because of closures, we still have access to the previous thing. So some of you may be thinking to yourself, if you are incredibly astute, great, but you haven't really answered the question. Why would anyone do this? Well, I'm going to try again to answer the question. Function factoring leads to generalizations, as we saw the generalization of iterating over a thing and doing stuff to it. That's the generalization. Generalizations facilitate small, well-tested, often used functions. Generalizations are predictable. Generalizations are ideally pure. You guys, anyone, what does pure mean?
You're talking functionally pure?
Functionally pure.
So it comes in, it gives you a return, but it doesn't modify the state of anything in a way that lives beyond the execution.
Yeah, it does nothing beyond what's inside of the context of the function, right? So promises, while are a good analogy for function composition, are strictly speaking not, because they are not pure. Logging goes to some outside thing, your screen, not pure. But that's okay, we can get around it. Ideally, they're pure. They don't mess with stuff outside themselves. Good generalizations mean most of your code is just a composition of existing tested functions. Imagine if you have a system that's been around for a little while and you've built up enough of these small units of code and they each have their own unit tests. Imagine you have some new feature. Imagine you just cobble together those functions, throw them into a pipe or a compose, and you're done. You have no unit tests to write. You have not written a unit. You might have a integration test to write, but whatever. There's just less to worry about. You don't have to worry that, am I mapping correctly? Am I doing this? Am I capitalizing this string correctly? I got to write a test for that again. Am I transforming this data correctly? You don't have to worry about that as much. You have taken these things you've already done a million times. They're tested. You've put them together. It's a lot easier. So why would anyone do this? Well, I like the matrix. What if I told you already were? Who writes React? Does it look familiar? 2 people? I know more than 2 people write React. I know this is a Node conference, but come on, guys. Yeah, it's a conference now, sorry. Yeah, I should add, this presentation was rejected from Utah.js, and I'm a little bit bitter about it. So you guys are the beneficiaries of my bitterness. So this is like a standard React, right? Nothing weird about this, right? JSX, good stuff. I've not seen a lot of heads. Yeah? Call me out. Call me a liar.
Well, really, all React is compose.
Man. You're right, it is. This is compiled JSX. Look familiar? It looked like that old stuff before I told you guys I wasn't helping, right? But if you wanted to, if you were the kind of person who's like, I don't do JSX, I write my React without JSX for some reason, you could write it like this. That's all it's doing. How's that read? How's that read compared to that? How's that read compared to that? Like, this is good. Don't get me wrong, I like this. This is good to read. But JSX is not native JavaScript. That's pretty easy to read, though. I mean, am I right? That's pretty good. Yeah. Or compose, if you prefer, which is the same order as that guy. Right? That's cool. Who writes Express? Barely more hands than React. I think you guys are sleeping. You ever written some middleware? middleware, React middleware, or React, Express middleware, something that looks like this. Well, that's functionally this, right? Call me a liar.
Async pipe.
Well, we're getting to that. Yeah. If you got rid of the next, which you can't because it's async, but you get what I'm saying. If you have synchronous middleware, which of course then brings me on to promises. Who's written promises? There's a few more hands. You have these then chains that, you do some stuff, then you do some stuff. And you guys return synchronous computations into a next then? Or do you always wait until you get to the next asynchronous thing before returning that promise to go to the next thing? Anyone made a habit of returning synchronous computations inside of a then? I do too, all the time. I would challenge you guys when you're writing promises. If you're forced into a promise because you have an asynchronous action that takes place, take the opportunity to really lean into functional composition here. You have this opportunity. Break down what you're trying to accomplish into very incremental things. What is the one thing you're doing right now? Do that one thing and nothing else. Does that work? Does that sentence work in English? Return that thing and then do a new then. It will make your application code read a lot easier, read a lot better. Your coworkers might be like, what the heck are you doing? You're being really inefficient. Tell them, prove it. Prove it that I am causing any kind of latency problem by having multiple thens. They're going to be hard pressed to do that. Yeah?
It helps big time with testing too. Usually some asynchronous operation that forces you into a promise chain. Well, if you can make that asynchronous operation just one of these functions, all the rest of them become unit testable, and you don't have to deal with databases anymore to test most of what you're doing.
Speaks the truth. Yeah. Small units, man. The smaller the unit, the better. So promises, right? They can be thought of as asynchronous, much like the Express example, asynchronous function compositions, which if we pretend pipe and compose were asynchronous, it would look something like this. This is pseudocode, but conceptually, this is what's happening. Did that address your question? All right.
We're good. You can easily write a pipe function that can handle async.
Oh, you could. Yes, absolutely. Especially when you have the async await shenanigans going on these days. So, kind of like the best friend you never knew was there. Whether you have realized it or not, you've been using function composition from the beginning of your JavaScript-ness, in all likelihood. Imagine what you can do now that you can recognize the pattern of what you're accomplishing, right? Now, hopefully, I've drawn back the curtains. Hopefully, as you go back and look at your code, you start to see function composition everywhere. And then you start thinking, well, wait a minute, if this is just function composition, why am I doing all this garbage in one place and making this more complicated? Why don't I factor this function, decide what kind of thing I'm doing, and then introduce that as a new component in the pipeline? That thing becomes easily testable, and then you just have this composition of things. It's so much better. So some of the advantages of function compositions is that it produces small, single responsibility units of code. It kind of encourages you into that mindset. It's easier to test, greater reuse of code. You find yourself using your library functions that either you wrote or that you bring in via some library like Lodash or Ramda or whatever. You use them everywhere. And that's a good thing because that stuff's tested. Your code isn't. So use the already tested stuff. You have greater confidence and predictability. It's declarative. What do we mean by declarative? It means make me a sandwich, not go to the refrigerator, open the refrigerator door, grab the bread, put the bread on the counter, take the twisty tie off. See how stupid that is? Why are we doing that? It lasts longer. You don't put bread in the fridge.
That fridge is full of other stuff.
Oh my goodness. No, if we keep bread on the counter, it goes bad in like 2 days. It's terrible.
We eat bread into
Apparently we stockpile bread. I don't know.
You have more children.
That's true.
How is this?
So it's declarative. You have a smaller surface area for bugs. If I can go back to look at something like this. Anywhere in here, do you see? I know this is pseudocode, but you imagine. Do you see logic in here at all? Do you see logic? Now there may be logic in here. It may be inside of something. I'm not a great speller. Something with that value, something with the previous value. There may be logic inside those individual functions, but those individual functions are lower level. We're not worried about that. We're at a higher level. What? Well, that's an integration, right? If you want to test that this works, you simply test that when I pass it context, I get this. There's no mocking. There's no garbage that you have to do, throw in there. It doesn't matter. You just say, you give it some junk, and it poops out whatever you expect it to, right? This is a function properly, a mathematical function. One thing in, one thing out. It's fantastic. So smaller surface area for bugs. This is very important, huge win. Fewer context switches when reading. Again, functional style programming and function composition kind of encourage you into this single layer of abstraction, not jumping between multiple layers of abstraction, which causes a context switch. Retains the same abstraction level more consistently, said that already. Easier to reason about, right? Isn't it? Let's look at, I guess some really bad named stuff, but you get the idea, hopefully.
Well, just on the surface, reasoning about JSX is a lot easier than just having to do it all.
Have you ever seen React code where I've implemented an if component? You ever seen that? An if component. So that you can write React in JSX as though you're writing imperative code. I'm like, why would you do that to yourself? You've been given this gift and you just flushed it down the toilet. Yeah. So there's a way. If you need an if, there's a thing called branch. It's amazing. Use that. Yeah.
More functions.
Yeah. Okay. So what else we got? Easier to reason about. Has some 50 years of battle testing, right? Did you guys know functional programming is older by far than object-oriented programming? By far. Functional programming predates computers. So think about that. Just putting that out there. Some disadvantages of function composition and function, the kind of thing generally is there is a steeper learning curve. Not because it's harder to understand, but because all of you were taught differently. You were taught, in my view, incorrectly. But there's going to be a steeper learning curve. You got to change your mentality. Much like event sourcing, it requires a different frame of mind. That's a learning curve. It's going to take some time. Not just you, but the next person that reads your code also is going to have that learning curve. It's theoretically less performant. The asterisk there because I actually haven't run into it in principle or in practice ever. We're talking about same order of magnitude, and particularly in web applications, your bottleneck is almost always going to be I/O. So just consider that. And if this is not performing, if it becomes a bottleneck, there are many ways to deal with that inside the functional concept, functional style, and function composition. So do not abandon it simply because of that. It's easily rectified if you need to. Because you've isolated the abstraction. You can go down into this and say, oh, the way I'm doing, I was using JSON.stringify, JSON.parse for my cloning. FT.com just recently posted. Did you guys read that? It slowed down their website by 10 times. Of course, they get a lot more traffic than you probably ever will. I'm not saying that you're not successful, but they really are successful. But if I don't know if they had this, but if they had their clone wrapped up in a function, then the implementation of that was easily changed to any other methodology, and that's all they had to do, and then ship it and off you go. For many of your cloning, it probably still is. FT probably deal with very, very large data sets, though.
Yeah, if you get over like a kilobyte,
Yeah.
Yeah.
But that's the cool thing. If you've done the abstractions right, then the implementation, you don't need to worry about it until you need to worry about it, and then that's all you need to worry about. And you don't have to go chasing it around all over the place. This is really cool stuff, guys. Right? These disadvantages are not even disadvantages. It's different from and obscured by most of the JavaScript you see. You're not going to come across. You're not going to be exposed to it as often as you are the scatter shot of stuff that's out there right now. It requires discipline. That's what your constraints. And that ultimately, all the objections I've heard boil down to that. But I have to constrain myself. I want everything in my toolbox. And whatever. If that's what you want, then good for you. I just won't work with you.
Ouch.
If you okay. That's actually, I don't have a last slide. The end. Any questions?
Error handling, particularly one of the most painful things with promises is, what do I do when I have to catch an error, and how do I know I'm catching it in the right place? At least for me. And I may be doing it wrong, but I want your thoughts.
Oh, okay. Well, this is kind of meant to be a primer on functional style programming and narrowing it to the concept of function composition. So this is just an inkling. However, there are many things out there that help you deal with problems such as this. I don't want to get into monads and things. Nullables. Well, I could, but I feel like that might be a bit much right now. Let me constrain it. If I may, constrain the question to dealing with promises specifically.
Okay.
You might be able to, depending on your needs, take your entire promise chain, assume a happy path all the way through, and do a catch just at the end of it, and handle it that way. If you have to catch differently under different scenarios, I have patterns. I don't know if I can explain them very easily without a more concrete example, but it would boil down to isolate your problem sets a little bit, right?
As I'm hearing you talk, what this comes down to in a more general sense is I've got a branching condition in the middle of my pipe, which isn't a single pipe anymore. So how do you deal with that in this concept?
It depends on if your branch comes back together or not.
Okay.
Right? So the general rule of thumb, when you have a branch, or when you have anything that's, I guess branching is not a purity question, but catching kind of is, because it's kind of similar to a null case, right? I have this thing, and if at any time this thing doesn't match my assumptions, I want to discard it and just abandon the pipe. Promises let you do that with a catch, which is why if you're able to, you can tack that catch onto the end of your promise chain. If you're using function composition, you start to get into concepts like functors and monads that let you wrap up the error case scenario and defer it to the very end of your pipeline and then deal with it there. But again, it's probably a little much for right now.
Yeah, and I'm actually realizing again as you spoke about that the real problem is when I need to catch, clean up, and then continue, which means I'm dealing with external state. But I've dealt with that too. And so in scenarios, you can throw a catch in at any point, and then if you return anything other than a promise.reject, and you do not throw, it will jump back into your then chain. So you can clean up and continue on. Like, I have assumptions. If this assumption isn't held valid, I'm going to fix my assumption and then continue down the pipe. I use that quite often. You just have to put that catch where that assumption could be invalidated. Yeah.
If that helps. Sorry, I don't have good examples right now. Any other questions? Yeah.
Earlier you said, what if you want to be able to use all your tools and whatever, fine, but I won't work with you. But in real life, what if you say, I have to build this new feature into what I've already built, and I want to try using functional programming for this thing. Is that just, it's like, well, sorry, you had to have done it from
No. Good.
Do the two things ever work together?
That's a very good question. It's a very good question, and I was being a little tongue-in-cheek with that. And really kind of I'm addressing mentality. If I would have a difficult, let me back up. I do have a difficult time currently in my current situation, working effectively with people who steadfastly refuse to acknowledge any benefit in this style at all. That said, JavaScript's a fantastic language because it's multi-paradigm. And so you can experiment with functional style programming or function composition in isolated areas in small ways inside of a larger object-oriented code base, or even just a backscatter all over the place spaghetti on the wall kind of code base. You can do that. In fact, I would highly encourage it. That's why we get back to function factoring, where we take our existing code base that maybe has a different methodology or no methodology at all, and we can carve out these slices and implement some constraints within that context and improve that bit of code, which is what refactoring is all about. Refactoring. So, absolutely. In fact, it's inevitable that will be the case, that you will have areas of pure functional style and areas of absolutely not functional style. Even in the vast majority of cases, that will be true. Good question. Yes?
So an observation with it, I don't know what folks do, but sometimes when I write a function, like I'll write function name, opening curly brace, closing, and then I'll fill up with comments that are English descriptions of what this function needs to do. Using a composition like this, the finished product looks a whole lot like those comments, only because there's an async step, there's a .NET in front of each of them.
Yeah. In fact, those if you're able to do that, if you're doing that, you write the comments. Those comments should probably represent a function by themselves because they are a unit that is doing one general. Like hopefully you can generalize that thing that you're doing, and now you just have a pipeline. And whereas you might have written those steps out in an imperative way, maybe you take your sentence and squish it together and camel case it, and that becomes the name of your function. I don't know. No, don't do that, because you want a generalization of it, not a specific implementation. So, but yeah, that's indicative of an opportunity for pipelining, function composition. Yeah.
When you show the why would you write these functions? It's interesting to think that you're writing the signature, the contract between the functions up front. So you don't care if it I don't care to go to the fridge and pull the bread out. Just go make me a sandwich.
Yeah.
So
Yeah.
you can abstract and enhance it all you want.
Absolutely, yeah.
In that contract.
Iterate on the implementation, but you have the contract beforehand. As long as you don't change the contract, that's great. And in fact, there's a notation for that. It's called Hindley-Milner, and it's really, really cool, and I suggest you learn it. You can begin writing, it replaces documentation and commenting code but it requires you to learn it. Again, another overhead. Once you learn it's really cool. Check it out. It's good stuff. Hindley-Milner is the name of it's a notation for documenting a signature of functions. And once you learn the notation, you can look at a signature and deduce what it's going to be doing. In many cases, the signature itself will tell you, I can see this is a filter. It can't be anything other than a filter because of the signature. So, yeah. Good question. Anything else? I'm waiting for Julia to correct me on some of this because I know she knows a lot of this already. All right, well, thank you guys. Thank you.